Record. All right, you should be able to see my screen, right?
Yes, sir.
1 second here. What is this? All right. Too many screens open. Okay, so first things first, we got to pull up your study, right? So if we go to forms.google.com. And yours is the automated flight, right? This one.
Yeah.
Okay. So I looked at this. It's actually looking pretty good. We got 15 responses, which is the minimum that we needed. So it's good. We're gonna get some strength in the data. I was hoping for about 30. I sent it to a couple classes. I didn't push as hard on my side just because the IRB setup here is different than what I'm used to in Florida, and it took a lot longer than I would have liked, but it is what it is. So we're going to download the responses, and this is what you get. All right, when you get this is what we need to do. So if you just follow along, let me know if you need me to pause at any point, and I will stop or explain a little bit more in more detail. So what we want to do is clean this data up a little bit. So I'm going to delete these two rows. How strong are you guys with Excel? Do you guys use Excel a lot in other classes, or have been, taking a class in Excel?
I am pretty much worthless at Excel. I think I've used it once in my life.
Okay, so we're gonna learn some basic Excel. We're gonna learn some basic Excel.
Yeah, it works for me.
So
I use it at work occasionally, but yeah, nothing like equations or anything. So
okay, great. So hopefully this will give you some good tools to use maybe in the future if you ever come across a job that requires you to use some data analysis. So the first thing I like to do is wrap the text so I can see this row. And when you look at this, you can tell there were 5 items for each section, right? So 6. So this is for the 2 pilots. These responses, each one of these rows is an individual's response for each of these questions. So I like to separate them. So I select 3 rows here, right click and insert. What it does is it just makes some blank columns so I can add some more information here. I do the same thing for the second set of data, which is right here. This is where it's 1 pilot and automated. So I'll separate that again, select the 3 columns, insert, right click and click insert. That will basically open up 3 blank columns so I have more space to work with. And then I do the same thing over here. Okay, so it looks like someone didn't really do it properly the first time around. There's some blanks over here. So I'm going to delete, right click and delete this row because that individual didn't do all the questions. So these questions, if we remember from the study, the way you set it up, the first set is 2 pilots, right? So this is the 2 pilots. This is 1 pilot and automated. And then this is no pilots, fully automated, right?
Yep.
And what I want to do, because this scale, it's asking a similar question 6 times to give, and then asking the individual how they feel about it based off a 5-point Likert scale. The way we do that is we want to find the average score of this individual's willingness to fly with that scenario. And then the way to do that is if you go to this cell over here at the end of this row, hit equals, average, open the brackets, and then select the set of data that you want to average, and then close the brackets. And that gives you an answer. Then you can go to the right.
In the brackets, you just hit 2 for row 2? Is that what you did?
If you look over here, it's from A2, and then this colon means through F2. So from A2 to
Okay.
F2. A shortcut that I use a lot is if you know you're going from right to left, I just do average brackets. If you have a Mac, it's Command. If you have a Windows, it's Control. So I use Command Shift and then the left arrow key. So click this button, Shift, Command, left arrow key. It will select everything to the left of it. Or you can just type it out, or you can click and drag using your mouse. Either one works. Okay.
Yeah, I guess Brandon's Zoom crashed, so I just got him on FaceTime listening.
Okay. Is it working? Is it working out? Do you need to try and get back on, or do you want to just use your FaceTime?
Yeah, he says he's gonna try and get back on, but he can hear on FaceTime.
Okay, and it's being recorded, so we can at least you can watch it as well again. All right, so then since it's the same equation in the same set of rows, we're going to copy. That's a little too much. Copy this. Select the set of cells you want to copy the equation to, and hit paste. I did Command V, Control V is the Windows version, or edit. Click edit and then paste. Okay.
Okay.
So these are the scores, the average scores of the willingness to fly for each individual. I like to make it to just basically 3 significant figures. So I decrease the decimal over here until it's basically 3 significant figures or 2 decimal places, either one. Okay.
Okay.
So that gives me some data. And to help me out, I like to see if there is an actual change with each set of questions. So I'm going to average again this data. And what that tells me, this piece of information right here tells me that the average willingness to fly for all the people that we got from this scenario is pretty high, 4.81. They're pretty willing to fly with 2 pilots. You got that?
Yep. All right, Brandon's back on now.
Okay, great. And then we do the same thing for the 1 pilot and automated. The same thing we did over here, the left-hand side for the right-hand side. So I'm just gonna, what I did was I copied this set of data, this set of equations, and what Excel will do is actually fix it to these data cells from J to O. So if I hit paste, there you go. We've got all the data set already done.
So you just have to copy it from the first one, the G column, over to the
and then
P.
paste it over to the P column, because what it does, if we look at the equation here, it still uses the average, the code for average, but then what it's done is it's shifted it over to J to O instead of A to F. It kind of knows that, oh, you want to do the average from these guys if you're copying the cell over.
Yeah. Okay.
And I'm going to show you a different thing that you need to do if you don't want it to move those cells, but we want it to actually follow along with our thought process and move the cells. So there you go. We've got the average. You can see it's dropped down a little bit, right? That's actually pretty good. That's based off your hypothesis. Remember, your hypothesis is theoretically the less automated. I think that was your hypothesis. If I
Yeah, the
remember
less
correctly.
automated it gets, the less people that want to fly.
Or sorry, the less pilots it gets, right?
Or yeah, the less pilots. Yeah.
Yeah. So there you go. We've got one. We don't know if it's statistically significant, but we can kind of see already it's dropping, right? And you can see we're going to do the same thing over here. Paste that. Oh, sorry. I need to copy the, let me clear that. That didn't copy properly. Clear contents. All right. So we're going to copy this set of data and paste it. There you go. And now we have another set of average. Look at that. That's actually pretty cool. It's following a trend, a downward trend, right?
Yep.
So if I were to quickly graph this, if I made this into a quick graph, we could say condition and let's see here. Condition is 2 pilots, one pilot, no pilot, right? We make this the average, and we just say it's 4.81, 3.27, 2.15. Based off this, if I select that data set, insert, and actually make it a chart, a 3D column, you can see that it is dropping right there.
Wait, it just turned those numbers into a graph?
Yep.
Wow, Excel's pretty cool.
Right? And so you can visually see the drop, right, from 5. And we want to change a couple things here. So if I just click in the chart and I go to format, right, you can start doing a couple different things here. So let me see here. Actually, I like to double click it, and that usually brings up, if you double click anything in the chart, it'll bring up this side column over here. And you can change the bounds. I'm going to change it to 5 because I know that's the maximum. So there you go. See how that changed that?
Yep.
And I'll keep it in increments of 0.5. That's fine. And what I like to do is just change the color for each section, just so that it looks a little prettier, to be honest with you. So if I double click the one pilot, let's just say I want it to be orange, and then the no pilot, let's make that one red. There you go. We got, actually, let's make one pilot kind of the yellow or something. Oop, that didn't do it right. I got to double click it. There you go. There you go. So now you can see 3 different conditions, 2 pilots, 1 pilot, no pilot. And you've got a nice little graph to put into your presentation or your paper. Because if I pull up real quick, I loaded this in the UAA template. So here you go. See, you see where we're going with this? This is basically your final presentation. This is what we call a research poster. It's all in one big poster, it's just the basic concepts of the study. And there's in each one, there's a graph, depending on what graphs you want to use and things like that. So right there, you've got one graph you can throw in this template. Following so far?
Yep. So this
Yep.
is what me and Brandon are going to work on together, right?
Yeah, this is your final presentation, and then what you want to do is make a recording, like kind of like you did in the CFI course, Cody. Just a recording going over the topic, and you can split that accordingly or do it on Zoom or however way you want to do it. That's fine with me. But yeah, this is the final presentation, and then the paper. Since you already gave me proposals, you can skip the first half of the paper. And go straight down. I uploaded this as well. This is a final paper example. And in this example, the discussion and future studies were not long enough or not big enough. I would like an abstract, but then you can skip the introduction, purpose statement, significance. You do want limitations and delimitations because we didn't do that in the proposal per se, or it needs to be updated for the final paper.
Yep.
You can skip the background because you already did that. That's fine. Just delete that. You don't need to put that in. And you can skip the research hypothesis because you showed me that already. It's really methodology. You kind of did that already as well. You can skip that right down. You're really in the final paper. I'm looking at data collection, analysis, and results, as well as the discussion, that should be pretty big in terms of what did the results tell you, what the limitations in future research is, what you could do to expand on this research, what survey could you increase, or what could you do to make this a better study in real life without COVID restrictions per se, and then the conclusion, and that's it. That's your final paper.
Okay, so just pretty much use my proposal document and just add and expand on the other things that we already did.
Yeah.
And just make it a different color, red or something, so you can see what we did.
Yeah, so one color for you, one color for Brandon. So I just see that you guys split it evenly. That's the only problem with group projects is inevitably if you unfortunately get a bad group, it seems like you two are going to work well together. But you get groups that someone ends up inevitably doing all the work and the other person doesn't. So I think that's not fair. So I try to make it where it's clear who did what.
Okay.
Absolutely. Yeah, no, that's easy enough.
Yeah, it's no fighting in that sense. It's like, hey, that's what I got. I can tell who did more work than the other, All right, we're not done here yet, though. This is just the basics, right? let me
Yep.
show you a couple more things. So same thing. I also like to know, because under results, and this wasn't done by this example student, you need to give some descriptive results, right? So over here, in the results, all he did was tell me that there was 98 participants. Well, you need some more descriptive statistics than just how many participants. So you want to say, what's the average age? So you can say the average age, you know, same thing. It's good practice too, to get the hang of this. Was the average age of my participants were 27.5. I'm going to
When
show
you
you.
highlight, do you just hit equal or enter?
Yeah.
Return, I mean.
Yep.
Okay.
Let me show you another thing that's really cool in Excel that I'm if any of you end up going into a consulting field or anything like that in aviation, I did this in aviation safety. I showed them how to do this because I've had students who go into a safety consulting job or just a basic aviation consulting job. I had a student who did aviation management and professional piloting, and then decided to go to Booz Allen Hamilton for aviation research and analysis. And they basically gave him an Excel sheet and was like, hey, show me the data with this information. And they gave him some questions to do, some basic formulas and things like that. And he wasn't sure how to do it. So just showing you some of these things could hopefully help you out in future potential options, right? So what we're going to do is we want to know how many males, females, and prefer not to say came out of the gender side. We're going to count the number of times it came up in a particular row, right? It's a lot. This is a small set of data, but imagine we have 5,000 of them and we don't want to manually count it, right? There is an actual statement you could use. It's called count if. So the count if means count how many if it falls under male, female, or prefer not to say. So if I do the count if, open the brackets, the range is the set of data I want, and I can select a bunch of them. So where do I want to count how many times the word male comes up, female, or prefer not to say comes up?
Okay.
So I just want to look at this set of data, this part of the data, right? That's my range. You see what it did?
Yep.
Yep.
And then the criteria, I put the comma, hit space, and the criteria, I set it up to be to the left-hand side of the cell right here, male, right? So you could either do it that way, or the other way you could do it is open the brackets. If it's a string, a set of letters, it's called a string, put quotation marks and hit what you want it to say, like that, right? And look at that, 6. It counted it 6 times.
Okay.
If you don't do the brackets and you already wrote it out in the cell beforehand, you just click the cell that you want and then hit enter. Boom, 6. Now, the problem with this, if I copy this cell and I go down to female, what's going to happen is it's going to change this range. I don't want it to change the range. The trick to that is to put a $sign before the range that you want, the cell range that you want. This $sign means do not move the box that I selected. Let me show you what happens if I don't put the $signs, okay? So if I copy this and go to female, it's going to give me 6 as well, because look at this. If I click this, you see how it moved down one cell because I moved down one cell?
Yep.
So that's not going to work. So what I want to do is put $sign, and look at this. It still gives me 6 because that is what it was. But now if I look at the, that didn't work as well as I thought it would. 1 second. Did I do something wrong here? Oh, yes, that's why. 1 second. I got to do it first from where I want to copy it. The $sign to $sign, copy, paste that. Now take a look at the range. Oh boy, that didn't work at all. I apologize. Why did I not? Am I not doing this right? There you go. That's what you need to do. There you go.
Okay.
See how it stayed? I put the $ before the letters, the cell name and the cell number that I want it to stay on, as well as the cell name and the cell letter. So I just want it to stay in that range. That's advanced. You don't need to worry about that. I'm just showing you how you could do that. So the same, now that I did that correctly, I can copy paste that. There you go. And that, prefer not to say, prefer, it has to be the same way you type it, prefer not to say. There you go, 1. So now you have yourself a set of data that tells you how many males, females, and prefer not to says you got from that data set. Again, it's only 15, so it's pretty easy. Insert, you can also insert a chart.
And these two charts we can put in our proposal, or not a proposal, but our final document too, right?
Yep, please do. Because it's important to know how many, because you could say to yourself, okay, if all my respondents were male, as a future study, I want to be like, hey, maybe males are going to give me a different answer than females, right? So I would need to replicate the study and make sure I get a nicer split of male to female, or get all females next time if I can. You see what I'm saying?
Yeah.
So while in this case, it didn't really matter too much because we only had 15 respondents, but also it's pretty evenly split, 6 to 7 really male to females, and 1 we're not sure of, but that's good enough where it can say, okay, there's really not going to be a gender effect. There's whatever the results are should be even between male and female, theoretically. Okay. All right, and then we may want to know how many instrument, commercial, private, student, pilot, and CFIs responded to this study. Wrong one. Just so you can see how it's all done again. There you go. Pretty awesome, right? What it can do in terms of data analysis.
It's pretty handy.
Yep.
Yep.
You just got to know how to use it.
Yeah, for sure. And then you can do another bar graph for this one, because it makes sense to be a bar graph just to see the difference. How many, or a pie chart or bar graph would work. And there you go. So you've got yourself some basic, what we call descriptive data. So we've got, quite a few instrument and private students responding, not so many commercial student and CFIs. So that might tell us, again, this is all inferring. We're making inferences from the data that we got. We don't know for sure yet until we do another study or expand on. That's the whole point of research, is to expand on things that we already collected, right? We could tell ourselves, well, since most of our respondents are private instrument, maybe commercial pilots might find that, hey, automation is not a big deal. Maybe they'll give you a different set of results than you get over here if you only studied commercial pilots, because they maybe understand a bit better automation, things like that. Those are the inferences. Again, we're kind of making inferences, or we're trying to make things fit off the data that we've got. Does that make sense?
Yep.
Yep.
All right. So now this is the starting point of your results analysis. Okay, this is what we got. We do see that there is a trend, downward trend. People are less likely to fly when there's no pilots in the cockpit, even though we did say that, hey, in the military, they do this already. They have automated flights. Everything is very automated. There's nothing that would stop us from not having a situation where no pilots are in the cockpit. It still could be safe, right? All right, well, we want to see if statistically, remember, the whole point is to do that t-test or Mann-Whitney U-test, the statistical analysis that I showed you that you can do with this data set. I don't know if you still have access to SPSS, so I'll probably give you the results to this, but I would like you to maybe try it out on your own. But we see that there is a downward trend, so you could discuss this in your discussion point. So under results, that's the overall, but then when you get to discussion, you could say, there was a downward trend. So this does tell us that less likely people are less likely to fly with no pilots, but it didn't drop as much with one pilot and one automated, right? So maybe there's a potential for short trips that people would be more willing to do commercial flights with one pilot and then the rest of the cockpit automated, right? The flight being automated in that sense. So that's there. Now let's do it statistically. So if we go into SPSS, I was doing some work here earlier. Let me pull up. So we've got to, what we want to do is copy the 3 scenarios. So what we're doing here is we're going to copy these 3. This is one set. This is set 2 with the one pilot. So I'm just copying and pasting it over here. And then this is the 3rd set. So we got 3 setups here, right? So if we just change the variable view, I'm going to change the names here to 2 pilots. Oops. Doesn't like numbers off the bat, so we got to change it to 2 pilots, 1 pilot, and 0 pilot. Nope, that's not going to like that. No pilot. All right, cool. So we've got ourselves 3 sets of data, right? And remember, we want to do either a Man-Whitney U, and since there's 3 of them, we could do an ANOVA, but we're not going to do that. We're going to just compare the 2 pilots versus 1 pilot, 2 pilots versus no pilot. So we're kind of doing this the long way around. There's another way to do it faster, but that's for a more advanced class. So we go to Analyze. If we remember, Analyze, non-parametric test, because this is the reason why we do what's called a non-parametric test is because it's not a interval type test. It's not a 0 to 100 test. It's a Likert scale. So we do non-parametric, legacy dialogues. It's a one sample? Yeah. Nope, not 1 sample, excuse me. Bear with me. Non-parametric legacy dialogue. Two related samples, that's it. Because it's a related sample, it's the same person responding to either 2 pilots, 1 pilot, or no pilot. Okay, and we're doing a Wilcoxon, that's what we want. A Wilcoxon Man-Whitney U is the same one. That's the type of test. I went over that in the statistics portion. We just want to see if there's a statistical difference between the responses between 2 pilots and no pilots, 2 pilots versus 1 pilot versus no pilot. So we're going to get 3 sets of results. So I'm going to do first the 2 pilots versus, why is this already here though? Oh, it's because I was doing work earlier. Okay, I'm clearing this out. Just give me a second. All right, we're on business. 2 pilots versus the no pilot, right? Why is it not letting me hit OK? There you go. Okay. You know what? It helps if I just restart. Bear with me, guys. Sorry, I need to set a new, because I was playing around with too many other things, so it's probably not liking it. Let's try that from scratch. Let's try that again. So we'll copy this one. You guys still on?
Yep.
Okay, so just bear with me. I'm just making this cleaned up here. Right, non-parametric test, 2 related samples. So we want, and we'll do 2 pilot versus the no pilot. Let's see if there's a significant difference between the 2. There you go. Look at that. there is a statistical significance. Do you remember why? Because look at this number. It's less than what? 0.05. If it's less than 0.05, that means your results is statistically significant. That means that your analysis between the two groups is provides evidence that there is a difference between people who are willing to fly with 2 pilots versus no pilots. People really do not want to fly with no pilots. It does not prove it. We cannot use the word prove in any type of research. The only time you can prove something is in physics, basically. Physics is the only science where you can really prove something. Even biology, you can't really always prove. Physics and chemistry, I take that back. Biology sometimes is a little not proving, it's more providing evidence that supports your hypothesis. So in this case, you can say that your statistically, there's significance. It provides evidence that there is a significant difference between people who are willing to fly with pilots versus no pilots. People do not want to fly with no pilots. That's basically what it's telling you. Does that make sense?
Yeah.
And if you don't remember, you can always go to Laird statistics and then type in Wilcoxon sign rank test. If you click on that, I love Laird statistics. I use it a lot when I'm doing studies. It basically helps you write it out. So, and how to do it. So it shows you how to do it all. And then when you go all the way down to the bottom, here you go. This is your test statistic table. You want this in your paper, or you could put it in your paper, but then here's how you would respond to the answer. So you'd say, in your particular example, you're going to have 3 results, 3 sets of these statements. A Wilcoxon signed rank test showed that a 2-pilot cockpit configuration. So you're just changing the sentence. Here in this case, it says it did not elicit, but you did, elicited a statistically significant difference between, instead of the lower back pain concept, between or with a cockpit with no pilots. And then you put the score, Z score, and the P equals whatever. In this case, your Z is negative 3.189. P is less than 0.001, which means it's statistically significant. And you don't need to put this last sentence in. So does that make sense? This one sentence, you're just going to adjust it slightly to fit your results. Instead of, in this case, they're talking about acupuncture treatment. You are talking between 2 groups or 2 scenarios. Scenario 1 with no pilot, or scenario 1 with 2 pilots. Scenario 2 is without pilots. So that's how you would set it up. Let's do the same thing. See if there's a statistical difference between the 1 pilot versus no pilot. There is a statistical difference with your group of people that it's less than 0.05, right? So as long as it's below 0.05, it's positive, it's statistically significant. And then one last time, let's see if there's a statistical difference between the 2 pilot and the 1 pilot. If there's less, they really don't like flying with the 1 less pilot, basically. Oops. Yep, statistically significant as well. So there is significantly a difference, a drop in willingness to fly. This is actually accurate. That if we were to expand this research study to a larger population, let's say we got 1,000 people to do this survey, we would theoretically be likely to see, statistically likely to see this trend, that it's going to decrease as less pilots are in the cockpit. So in terms of your discussion, you want to talk about the implications of this study. So what are the implications of this study? Let me just kind of spitball a little that you can think in your head, and that's what you're going to expand on in your discussion in terms of the significance of the study. So one of the things we want to do is potentially reduce the cost, right, of the airline business. It's not really good for pilots, in all fairness, because that means we get less jobs. But in the whole goal of this is, A, we want to expand the airline business, potentially allow for more flights with less pilots, less need for pilots, even though we want pilots to have jobs and all that stuff. Don't get me wrong with that. That was theoretically the idea, right? Also, maybe shift towards maybe a shorter distance flights, having shorter distance flights being kind of like automated drone flights, right? That will allow more servicing to a given area. Think of the lower 48 and maybe even in Alaska, just in Alaska alone. And so the idea is that the reason why we kind of wanted to look at this when I was talking with Cody was more like, hey, with COVID and everything, one of the significances, maybe this would allow for more flights to be available. Maybe more people would be willing to fly if there's a smaller airplane with automated flights. So think of, a small Pilatus, but it's automated, so less likelihood of spreading, things like COVID in that sense. Just a theory, right? Would people be willing to fly? And in this case, we find that not so much. While it's not a very low number, it's still significantly different than the 2-pilot scenario. So we're also trying to find a way to be efficient with respect to our cockpit configuration for future flights and the future of aviation. And so with that said, we do see that while the general public do not want to fly with no pilots, and granted, we mostly surveyed pilots themselves, there is a possibility that the 1-pilot configuration for commercial flights might be a potential option in the future. And while this may mean that there's less, while you may think that, oh, there's going to be less pilots that may be able to get jobs, that might not be the case. If we find a way to have the less need for 2 pilots in a cockpit, you might actually have a greater volume of flights being available, because you can now put, instead of having 2 pilots in one cockpit and having 2 people be taken up for that one flight, you can have 2 flights, 1 pilot in each airplane to go fly. That's just part of the discussion, right? The whole point of the study is to see, is there a way forward with respect to cockpit configuration for, let's say, shorter flights or within, let's say a 300, 400 mile radius flight, things like that, like you did, Anchorage to Fairbanks. If that could be automated and you have more flights going there back and forth without the restraint of pilots, the need for more pilots, we may be able to get the airlines to, offer more flights, offer more seats, things like that. That was the concept that I could see this study going towards. Does that make sense?
Yep. So talking about, ways that maybe the study could be furthered in the future, would that possibly be something like, obviously, we're doing all pilots right now in terms of the data. So would something be like open it up to the general public and see how the general public feels, flying with full automation versus just, how pilots feel flying with full automation? So
absolutely. Yeah, that would be your future recommendation. So like here in the paper, limitations in future research. Well, we were limited because of COVID and because of the class and things like that. We had limited responses. So, and I feel like in this particular example, this limitations in future research really didn't expand enough. It's so short. It could have been like at least 2 more paragraphs of, what would we do for future research? Expand it to more people. Maybe change the configurations a little bit, explain the scenario a little bit better. Maybe give them, would a 15 or a 5 to 10 minute video or lesson on automation change their mind? The reliability of automation, like maybe have them understand how automation works. Would that education change their perception of automated flight? Things like that. This actually plays.
We could also do since there's only 1 pilot, that tickets would be cheaper.
Yeah.
Maybe.
Yeah. You could say that, okay, there's going to be a reduction in cost of flights. You'd say, okay, what if we said that the flights would be 10% cheaper than it is right now, because, you know, there's less personnel required for each flight, or there's, you know, things like that. One of the things also that you might want to consider in that discussion is, oh, what was I thinking? I was thinking of something and then I just kind of lost my track of thought. Oh, the MCAS. You guys are aware of the 737 MAX, the situation with that?
Yeah.
Yep.
So, you know, there's a lot of articles right now kind of bashing the 737 MAX and, hey, do you trust the flight and all that stuff, right? And this kind of ties into that, you know, is there a loss in trust in automation and software and aviation? And this paper your results kind of show that there is a lack of faith in automation. So the future research would be, how can we change, or how can we make sure that people, pilots and non-pilots, users, passengers, will trust automation a little bit more, right? That would be a future research. What can we do to make sure that people trust automation more, be more willing to fly things like the 737 MAX, or airplanes that are, you know, if any of you guys fly drones, any of those commercial drones now, they're so automated. You can just click a few buttons and that thing will fly exactly the way you want it to fly, regardless of the weather, regardless of certain situations. We're getting to that. We're getting in the near future, you know, within 10 to 15 years, I do see automated short flights. I don't see long commercial, either, you know, anything that's more than 3 hours long being fully automated. There's got to be pilots in there, but, you know, a short hop, an hour flight down the East Coast, if you're in the East Coast from Florida to Washington, D.C., I don't see why that can't be fully automated with all the technology we've got out there with ADS-B, Cat 3, instrument approaches, all that stuff's pretty much automated. You know what I mean?
Mm-hmm.
So, so this was a fun study. You guys got some good results. I think they're all statistically significant. Do you still have access to, actually, you know what? I'm just gonna, see if that worked. Let me see if I can give this to you where, oh, this is SPV. I want it as a PDF. I'll just send this to you as an email. Does that work? That way you have it, and you don't have to do the statistical. This is not a statistics class, but you do need to know how to respond to it.
Yep. Okay.
Yeah, that works.
You know what? Actually, let's see. Why is this not letting me print it? I'll figure it out. I'll send it to you guys by email.
Okay.
You got it.
All right. Why is this not letting me save it as PDF though? I have to sit down and figure out how to do that. I'll get it to you as soon as I can. All right.
Okay.
It works
So
for
for
me.
the Excel spreadsheet, are you sending us that base layer and then we're doing all the graphs for it, or do we need to create that base?
Yeah, I want you guys to do it. It's good practice. You can download it from your Google Forms, what you sent me with your Google Forms. I can actually send it to you as well.
Whew.
I might have to download it again.
Okay, so you just go to that Google Forms and you download it into the.
It will download as a CSV file, yes.
Okay, that's the part I missed. I didn't know how you got all the numbers on there.
Yeah, let me show it to you one more time just so you see it. If you go to Google Forms, so this is in Google Forms, and you click the form that you created, that automated flight.
Yep.
And then you go to so you've got the questions, what you did and created. You go to responses, the ellipsis, the 3 ellipsis right here. Download responses. It'll download it, and it should look like this. So let me send it to you guys. So you don't have to do that, but just so you know how to do it, it's there.
Okay.
It's called data raw, and then I got to sit down and figure out how to print this again as a PDF so you can have it.
Okay.
All right. Is that helpful? So all you got left to do, and you've got until, I'd like, because I mean, my schedule kind of got messed up a little bit with the whole IRB thing. Now that I know how long it takes and what it entails, I'm going to change it up for next time I teach this course. It's December 2nd, and next week is the final. This is finals week, right?
Yep.
Yep.
I'd like something by Wednesday the 9th, just in case any issues that come up, I can fix and, you know, give you feedback. That way, the drop deadline is Friday the 11th of next week.
Okay.
But I think that should be enough time to give you one full whole week to write out all your, you know what I mean?
Yeah, because it's really
yeah.
not a ton to write into that final
No,
document.
it's not. It is going to take a couple hours of just like, you know, getting the data done, figuring out how you want to write it, how you want to split the discussion part, the results part, things like that.
What did you
And
use to make the poster?
it's so if you go to, I already gave you the template,
Oh, you did. Okay. Oh, yeah, I remember that. Okay.
but I updated the template. If you go to, I did it where it shows UAA now. Go to your class. You go to course content. Go all the way down. Here's your example final paper, and then your UAA poster template for presentation. Click on that, and that will bring up this. And then you just, you know, change. Right?
Yep. And then just put all our data.
And just fix the background. The background needs to just be enough. So think of this as an elevator pitch. Imagine, so the way this poster works is you've got, you're standing around in a room. So we used to do poster sessions. So you'd stand around, there's 5 other groups that are doing these. They've got a poster in the background, and people are walking around, and then they stop, look at your poster, get an idea of your poster and what you did and what the results are, and then ask you questions, right?
Okay.
And then they might ask you, okay, can you just explain your study a little bit more? And you'd kind of go through it. It's kind of like an elevator speech in that sense, an elevator pitch. And what you're going to do is build this and make an elevator pitch, a 5-minute to 10-minute max. I don't want it too long presentation on this. And it can just be, Cody, if you remember, and Brandon, if you don't, you can add, where is it on this thing? Record slideshow. You can just record an audio or video or whatever for just this slide, just to go over it. So
Okay. And then what we can do is I can do my 3 or 4 minute talk about it, and then Brandon can send you his 3 or 4 minute talk about it, and that'll be our presentation.
yeah,
Want
that's
us
fine.
kind of talking together.
Yeah, that would work too. Actually, if you want to separately do that portion, that'd work too. That'd be actually better, just so I can see that both of you understood the general concepts and what happened and how that worked. So you can make your own version of the presentation and then work together on the paper and the discussion points and all that. That's fine.
Okay.
Sweet.
Yeah, like I said, so just keep it straightforward. The purpose of the study should be that one sentence that you give the hypothesis. If you look at the methods, all right, why can't I zoom in here? Oh, it's because I started recording something and it just decided to. If you go into method, wish I could zoom in. I'm not sure why it's not letting me do that anymore. Reset. Nope. Oh, shoot. Don't do that. Why is it not letting me?
Slideshow, maybe. You go into slide.
Clear. Let me just clear it. There you go. Thanks. If you go to method, you can see here, I just did this is from the study. So you just change each one slightly. This is another one. I don't know why it just decided to be all funky on me. Let me just reopen that. Better. There you go. So you'll want to change this methodology just a slight bit. So change this to say whatever you need it to say for your methodology. Okay.
Okay.
And it's all there. It's pretty straightforward. What I'm doing is showing you the steps of this, like, a basic research study. You've got your hypotheses. It's pretty straightforward.
They put our graphs in there.
The graphs, and then results. Discuss your results, what your results were, and what you did with respect to that. It should be very similar to this, except you're going to have to change it to fit your study specifically, right? Your study is different than this one. And then limitations in future research. I would expand more on the future research side of things rather than the limitations. We know the limitations were COVID and timing and things like that. And then really your discussion is the key point. Like, what does this all mean? Why is this important? What does this tell us in aviation? What can we do with this data? What can we infer with this data? Does that make sense?
Yep.
Absolutely.
So while this only had 3 bullet points, I would make it 4, but really good, solid discussion points that if someone were to read it, they'd be like, oh yeah, that makes sense. That would, make sense for the discussion for this study. Cool.
Okay. Yeah.
All righty. Well, good luck, guys. Let me figure out and send this over to you shortly, and we'll get going here.
All right. Thank you very much.
All right. Have a good one.
You too.